Okay, for 7.3, hypothesis testing for means, that's what we've been doing. That's what we were doing in 7.2. It's just in 7.2 we were doing larger samples, and now we're doing smaller samples. So the processes by which you do this, by which you actually test, are almost identical. The main difference being we have to use a different table. I'm sure you know. If it is a small sample, we are using a T-table and not a Z-table. Z-tables are for sample sizes that are 30 or larger. So now we're doing small samples, which would be smaller than 30. So a lot of this is going to look very repetitive because it is. So hopefully that'll help you get it down because it's going to be similar to stuff we've already done. So there are 3 steps to finding critical values in a T distribution. You need to identify your level of significance. And again, we use the Greek letter alpha. It looks like kind of like a fish. Then you're going to calculate degrees of freedom. We've used that earlier. You remember how to calculate degrees of freedom. Degrees of freedom is calculated n minus 1. So your sample size and you take 1. It's an adjustment for the sample size. Then we are going to use our T-table to get T naught. And you have to keep in mind left, right, and two-tailed tests. And let me show you why that's why you really need to keep that in mind for a T-table. When you're finding a critical value in your T-table, the way that the table is made is a little bit different. So let me zoom in a little bit, see if you can see a little better. Oh, there we go. So up here at the top, see how it says this top header is area and one tail. Now it doesn't matter if it's left or right tailed, and you can tell by the little drawing. Your T-table only gives you, it's like absolute value. It gives you area only. So, and they are only tails. It does not, like a Z-table accumulates from the left. If you look at the image that they've shown on a Z-table, notice how they show it's shaded from the left all the way over to the Z. If you can see that, because I've got glare, sorry. There it is. You can see that it's shaded from the left all the way over to Z. That is not the way that T-tables work. T-tables are specifically just for the tails. T for tails. So these numbers in the middle are area. So this header at the top is the area in one tail. It doesn't matter if it's left or right. And then this is the area in two tails. So you just look at a different header. So with that in mind, let's try an example because I think that's probably the easiest way to figure this out. So it says for us to figure out the critical value, or the T naught, for a left-tailed test with an alpha of 0.01 and an N of 25. So my level of significance, they wrote for me, 0.01. My N is 25, so my degrees of freedom, 25 minus 1, my degrees of freedom is going to be 24. So I go to my T-table. It is a left tail, so it's one tail, at the 0.01 significance, so I'm looking at this header. Up here to 0.01, and I go down the side until I get to 24, and that gives me a T critical score of 2.492. Now, they put this over here because they want you to go ahead and sketch that graph. So I have to keep in mind, this is a left-tailed test. So yes, 2.492, that would be over here because remember, this is 0, 1, 2, negative 1, negative 2. And these are just standard deviations. So 2.492 would be over here, but it's a left-tailed test. So I have to remember that I need to make this negative 2.492. And I'll go over here to 2.492, somewhere over here, and shade. All right, so if you want to try number 2 yourself, pause the video, and then when you come back, I will work it real quick. So we're looking with a level of significance of 0.05. It is a left-tailed test. It's going to be one tail, and my degrees of freedom in this case is 14. So I'm going to go to my table, a one-tailed test at 0.05, and I'm going to run my finger down until I get to degrees of freedom 14, and I get 1.761. Again, it's a left-tailed test. It's going to be negative 1.761, and that would be around here somewhere. And I would shade. Okay? All right, this time, if you want to pause the video again, work it yourself. This time, it's a right-tailed test. Level of significance of 0.05, and N is 18, so my degrees of freedom will be 17. It is still a one-tailed test, so I'm using the one-tailed heading. And I get 1.740, but this is a right-tailed test, so I have to make sure that when I go to sketch this, that I sketch the correct thing. So T naught is positive 1.740, so that's going to be right here, shaded this way. That area that's shaded again, that's called a rejection region. And in just a little bit, we'll see if something's in the rejection region, we'll reject it. All right, so in this case, we've got a two-tailed test, so I'm going to use the two-tailed heading. So for a two-tailed test with an alpha of 0.10, and N of 29, this time I'm using a different heading. I'm using this one, area and two tails. So I'm going to go over here. My N is going to be 28. My DF is 28. So 2.763. Hold on. I just used the wrong one. I used 0.010, sorry. I need to use 0.10, there we go. 1.701. So my T critical is 1.701. That gives me one of them, but it's two-tailed. So that means if 1.701 is one of the tails, then negative 1.701 is the other tail. So you should have double rejection regions in this case. Or look something like that. Okay, next, the formula for the test statistic when N is less than 30 and a standard deviation is unknown. Now, don't worry, it's not another formula you have to remember, because first of all, you should have just remembered it for your test, but T equals sample mean minus the population mean over standard deviation divided by square root N. This stuff all goes together. This is a grouping symbol. That all goes together. So just be careful about how you put it in the calculator. I'd use a fraction bar. It makes it much simpler if you'll do that. Using that formula is exactly like using the formula that we used for z-scores. So that part should be easy and familiar because it's just like what we've already done. So next at the top of the page, it asks you how to calculate degrees of freedom. Well, we've been doing that already today, so I'm pretty sure you remember that. Degrees of freedom is just N minus 1. So here are the steps we're actually going to walk our way through a t-test, a hypothesis test using a t-test because it's a small sample. So first step, write the null and alternative. So you're going to write your H naught and your HA. Identify level of significance. alpha equals. Calculate degrees of freedom. df equals n minus 1. Then you'll find your critical values. For that, you use the t-table. Shade the rejection regions. Calculate your test statistic. Decide. Reject or fail to reject. And then interpret in terms of the claim. So remember, we have to make sure that when we interpret, that we're interpreting in terms of the claim that's being made. So remember, sometimes the claim is not the null. Sometimes the claim is the alternative. So you just always make sure that when you interpret, that you interpret in terms of the claim that's being made. First of all, it makes it a little easier for the reader to understand. But that's the reason we're testing. We're testing a claim that's being made. All right, let's see. So we're going to follow each step and write down each thing from each step. So Ms. Hogan needs car insurance for her Nissan Juke. Her insurance agent tells her that the mean cost to insure a 2012 Nissan Juke is at least $1,250. A random sample of 1,100 insurance quotes is a mean of $1,150 and a standard deviation of 62. Is there enough evidence to reject the claim at a level of significance of 0.05? Assume the population is normally distributed. All right, so our first step is to write the null and alternative hypothesis. So in order to do that, I need to find my claim. Her insurance agent tells her, or claims, mean cost is at least $1,250. So mean is greater than or equal to $1,250. Which means the complement to that is less than $1,250. So I identify my null as the one with equality. So this is the null, and this is the alternative. This also happens to be the claim. So when I come back to state my interpretation, that's going to be important. All right, next, identify the level of significance. Well, they've already done that. That's pretty easy. It's right here. Then I need to calculate degrees freedom. So the degrees of freedom, so let's see, this was 1. That's 2. Step 3, degrees of freedom. 11 minus 1, so 10. Step 4, find the critical values. So I'm going to use those degrees of freedom and my level of significance of 0.05. Is this a left-tailed test or a right-tailed test? Left-tailed, because remember you always go to the alternative hypothesis. It's a less than, so it's a left-tailed test. So it's one tail. So at a 0.05 significance, so 0.05 significance to 10, my T critical is 1.812. So T naught is 1.812. Now, it's a left-tailed test, so it's actually negative 1.182. So, let me get a different color to shade with. So, let's see. It's going to be up here. .812. All right, and then the next step, so those are my, I just shaded my rejection region. Now I need to calculate my test statistics. So Remember, that's going to be x bar minus the mean over standard deviation divided by square root n, or I can use s here since I don't have a population standard deviation. All right, so from my sample, the sample has a mean of 1150. That goes first. Minus the 1250 over standard deviation 62 divided by square root 11. Now be careful right here because we've already used degrees of freedom, and sometimes people will accidentally plug the degrees of freedom in there instead of your n value. So you need your actual n value to plug in right there. All right, so then you're going to plug that into your calculator. So let me show you again. I would use my fraction bar. So let me see if you can see that. There we go. So that's alpha y equals, and 1 gets me a fraction bar. So I have 1150 minus 1250 over, now I need another fraction bar here, the standard deviation of 62 over the square root of 11, and I get a test statistic of negative 5.35. Now, step 7 is to determine whether or not I'm going to reject the null. Well, so if I take negative 5.35 and I try to graph it here on my graph, this is negative 1, negative 2, negative 3 would be here, negative 4. I mean, we are way into the rejection region. So we reject the null. And this time, the null happens to also be my claim. So when I go to interpret this in context, I'm going to say we have evidence to suggest, or we have evidence we should reject. And instead of saying reject the null, it's the claim. So I'm going to say reject the claim that ensuring the 2012 Nissan Juke is $1,250 or more. All right, so you see it's very similar to what we did before. You just using your T critical instead of Z, and actually T is, I think, a little easier to use. So I hope that you find that to be true too.